Yeah, welcome everyone. I'm probably going to be the fourth that is going to thank Yuri. So Yuri, that's the fourth. Thank you. Also, I want to thank you for giving the introduction on GraphQL. It was a bit hard for me to know upfront like what everyone's experience with GraphQL was going to be. So I really like that you at least gave the basic demo, because I'm not going into the small details of GraphQL. Yeah, today I'm going to take a look at a bit of performance and a bit of security. I just want to give you guys a couple, I think it's about 7 or 8 pointers that things you should be looking at when you're using GraphQL. And if your solution, yeah, you have to find like the way to look at these things that's really important performance-wise and security-wise. So yeah, my name is Bryan. I'm the lead backend and also DevOps at Lively. So yeah, I lead the backend team, and we also have like a couple of guys for ops, like CD, CI, and things like that. Because we're an agency, we're making like a lot of different applications, so we have to figure out like a way to yeah, use the same stack over a lot of different applications. And that's of course one of the reasons that we started using GraphQL, because it's a spec, so every application that we built in GraphQL uses the same. Like for front-enders, it actually uses the same interface, right? So no matter if we build it on Node.js or we have some applications that are built on PHP. I mean, for front-enders that are programming React or Vue or Angular, they all have like the same interface, how they can talk to the backend. Okay, so GraphQL performance and security. I just want to give you a fair warning. I'm going to do a lot of demos, so I hope everyone can read it also in the back. Yeah, a bit of caution, probably much typos. I'm sorry for that, a lot of code. Many wrong applications when I'm switching to other applications, but I hope it's all going to be awesome, so let's do this. So performance-wise, I want to talk about 2 things. Yuri already said the first one, that is the N+1 problem and how you can solve this. And then the second thing that's really interesting is persistent queries. So yeah, let's take a look at what actually is the N+1 problem. So the N+1 problem is something that really arises from like how you interact with a database. As you can see here, for example, we do a query to get all the people from the database. And if we like don't write really performant code, we probably end up doing some kind of for loop with our ORM that is doing like the select star from the friendship. So it's just actually getting the friendship relation, but it's actually getting it for each person, right? So that's why it's N+1. This is the 1, and then for each person that you get here, you get like another extra query. So then you have like the N+1. Yeah, it's really easy when you just start out with GraphQL and you're not using like some kind of PostgreSQL or like some kind of automatically generated tools to hit this problem, and ORMs make it really, really easy to do this wrong. So yeah, I just want to show you a quick demo of that. I'm in an application that is basically what I just showed. Everyone can read it in the back, right? Okay, no. That is basically about persons and the friendship relation that is between those persons. So I have my terminal here. That is just the application that I started. And then we have Insomnia here that I'm going to use to run the GraphQL queries. So yeah, if I'm going to run this query, wait, I'll show you the code first for the first case. So what I actually did, we are using an ORM called Sequelize here. So we basically have a person model. It's active record pattern. So I can just say person.find1 and person.findAll for the people query. And of course, each person has a friends relationship. And what you can see here is like, here I'm getting a person, and here I'm like getting the person's friends, which this really made really easy by the ORM, right? It just exposes a method that you can say, okay, get friends, and it will do the query for you. So yeah, you could probably implement like this, but what you end up having is that if you're going to run this query, it will perform three queries here. One is because I am logged in, so like it's getting the actual user for me. Then it's getting the person. It's getting with a limit 1 because I built in some pagination for that. So it's getting the limit 1, and then it's getting the friendship for person 1, right? So there's one there. Can you read the gray in the back? I mean, it's saying person 1, so it's getting the friendship for that single person. What happens now if I increase this 1 to 2? It's going to give me another query, right? So it's getting 2 people here with the limit 2, but it's getting the friendships here for person with ID 1, and then it's getting the friendship there for person with ID 2, sorry. And if I get 3 people, I mean, here you can see clearly what the n+1 problem is, right? So you're getting another query for each time you increase the limit. So if I put 100 here, I would get 101 queries. So yeah, that is an interesting problem. That is, if you're not thinking about it, something you hit really fast using ORMs. So yeah, what can you do with that? Now, Yuri already gave like the example on data Lotus. So yeah, I want to show you an example of how you can use data Lotus. And one thing is just make sure if you instantiate data Lotus, always instantiate them on the context, the GraphQL context, because otherwise you end up having like, because data Lotus not only batch your request, but they also cache your request. And if you don't do it on the context, so it's not on a per user basis, then you're leaking like data to other users and other sessions. Yeah, so that is like, I'll share all these slides. They will be on GitHub, slides and code, so you can try everything yourself, and I'll make sure that the README is clear enough so you can just get started with this. It is written in Node.js, but for the PHP people or other. Are there any other languages here that I just spoke to you that you do PHP, but are there anyone else? Ruby? Okay, cool. Yeah, so if we are looking at the second case, in here, I'll show you the context first. So I created a helper method. So this is the context. Basically, you build up the context. It also has like this is the logged in user. I kind of faked it by just getting the user with ID 1. But I placed the data loaders on the context. So it's there are new instances of the data loader for each user request. And then I created some helper methods to create the data loaders for me. I'll show you the one with person here. Basically, what you can see is it takes you create a new data loader. That's just like the package that is built by the GraphQL and Facebook community, and you use that. I have to show the. So you basically use it like demos. You basically have to use it like this. So I get the context and I get the person's loader, and then I just load a single ID, right? And in this case, for example, for people, I do a load many on all the IDs I have. And if you then look at what's happening here, it's going to batch like all the IDs, and then it's doing the actual query to the database where it's doing a where in, like with all the IDs. And then yeah, something that I had to do is like, because the IDs can, for example, somewhere in the request you can have like a user request for ID 1, and then you have a request for user with ID 2, and then somewhere down the road you have a request for user with ID 1 again. And so what I had to do is that like all the incoming IDs, of course the ORM will get like all the users, but it's not going to give me the user with ID twice. With ID 1 it's not going to give me it twice, so I have to remap and do the find again to make sure that the incoming array of IDs is actually also the array set of models that is going out. Yeah, so basically what I did is I implemented the loader here and I implemented the loader there for the person and the people, and it's basically about the people. So let me switch to this one. Okay, so this is interesting. it's actually doing more queries here. It should, let me see, it's requesting the person here, then it's also requesting the person here. Oh, here's the date, here's doing, okay. So the user and the person are like from the other one. Here it's data loading the first user, so it's doing a where in, and that has to do with like people limit 1 will give back 1 person, right? I can add the name here so it makes a bit more sense. So if you, it's a bit, yeah, the interface is not really made for like doing it like this, but we're getting back 1 person, that's me, and then we're getting his friends, and my friends, and I only have 2 friends, I guess, yeah. So what it's actually doing is it's doing the data load here, so you also see like the where in here, and also the where in there. And here it's doing, that's the interesting part, it's doing, yeah, this one. It's doing a where in again, because if you look at it from the query perspective, the data loader can do like everything that's on the same level. It can do in parallel, but as soon as you nest the queries, it has to get like the first person before it can know whose friends, yeah, he or she has, and then it can do like the data loading of the person that are in there. So what's happening in here? It's getting me, and then it's getting 2 and 3. So those are Peter and Leon. So yeah, but that's if you increase it now, you're not getting more queries, right? It's still querying. It's querying more on the first part because I have the limit set to 2, so it's now getting ID 1 and 2. And down here you can see that it's only getting person 3 because if you look at the result now, I have Peter as a friend, for example, and Leon, and Peter has only 1 friend, and that's me. So it's not actually getting my information again here because it already got it here. So it's only getting the third one, and the other ones are just from the cache that it creates. That's basically what the data loader does. So I can increase it to 3 or 4. This is interesting, by the way. If I increase it to 3, you see that I have 1 less query, right? But that's because in the first part, like the data loader, on the first level, it's already getting 3 person. So that 5th query that's actually happening is only using the data from the data loader, because there are not more than those 3 people. So yeah, that's an interesting one. And of course, I can increase it to 5, and then yeah, you still have those amount of queries. Okay, so yeah, that's really easy. You can look it up how data loaders work, and of course there are data loaded. The pattern is also really well known, so you can most likely use it in any other language as well. So yeah, one thing I just want to say, this is basically how I think most of the people are using data loaders right now. But actually what we are doing, if you look at it from a data perspective, what we are actually getting, we are overfetching the person when we actually don't request any fields. And that is what is called like the difference between object-centric and field-centric data loading. And I'll show you exactly what that means. So in here, this is still the second case. So in here, we are saying that, okay, if I request a person, I give it an ID as an argument, so I get a certain person, for example. I'm already loading like the person, but in here I'm not really sure whether or not the person's information is actually requested, right? You can, of course, add the 4th argument and do something with AST parsing, but if you look at it from another perspective, you can say like, okay, in case 2, we were already data loading here, right? But we can also just return the ID and start data loading as soon as we know that we have to get some field of a person. So, for example, if I get the name here, only then do I want to data load the person, because then I know that I have to get some information from the DB. But if I only request the ID, or I even request nothing, I can just only request friends, right? Then I don't have to data load or load the person at all from the database. So yeah, if I look at that here. Oh. I didn't implement people on that one. Yeah, so this is interesting. I have to put in name here, for example. So if I request name here, what happens is it's going to get the person, right? And then of course, because I got all the friends, it also requests the friends, and then again it's requesting the persons of that friend. But if I remove this name, for example, I'm not actually requesting any data from the actual person. I'm only requesting its friends, and its friends is using another data loader, right? So if I run this query, it's going to give me 3 queries, and it's going to skip getting me as a person. While in the other way, if you use data loading to get the actual object, you would get the person, but you're not really using the data that is in there. And same holds for friends, of course. If I remove this one, you're going to get, because you're already getting the IDs to data load, but you don't actually have to if you only request ID. Yeah, and this is interesting because if you, for example, have a person and you want to get the friends of the friends, then it's going to be a bit more efficient in how it's going to get like the actual friends of friends data and how you actually render that. Okay. So yeah, that's basically what I wanted to say about data loaders. Then another thing I wanted to take a look at that is something that you see, like people that are really REST heavy are always saying like, okay, GraphQL is cool, but I want to cache and I have to do everything in post request, or that's like the main perception that you get if you start with GraphQL. Insomnia, if you choose GraphQL, it automatically switches to a post request. You know, it's like everyone thinks that is the only solution that is out there. But if you're going to use persistent queries, you can use GET requests, and you can cache all your queries if you want to. And it also allows for easy whitelisting, query whitelisting. I'll show it in a bit. This is from the Apollo side. They make it really easy to implement this if you're using Apollo client and Apollo server. So basically what's happening normally is that you create a hash of the query that you're going to call, and you provide the backend with that hash or the query and the hash of that query, and the backend will like save the mapping between the hash and the actual query. And what you can do later on is like only request the hash without actually providing the query, and when it finds it, it will give you the response immediately, without actually sending the actual query. And of course, like if you're doing a GET request, you have to like provide your query inside the GET parameters, and that can only be so long because URLs have some kind of ISO standard, and yeah, so that's basically how you can in the end get a GET request with cache by using those hashes. Yeah, these are examples. So this would be a call. This is how you would use it. You're telling it, okay, I have a persistent query. Version 1 is like, I think it's just what it is right now. They made it for, I think, future changes. And you provided the hash, and then, of course, the backend will return with, okay, that query isn't found yet because you didn't provide the actual query. And if the hash isn't found, you will get this error message that I don't know what I have to return. And then if you use it this way, you can also add the query, and it will, create a mapping for you, and you can then use the persistent query, so you can only query based on the hash. So yeah, I want to show you that. What I did here is basically I'm using Apollo server in most of my cases here. what you can do here is, okay, I turn on persistent queries. In this case, it's Redis cache, but you can have like mem cache or in-memory cache or whatever you like. And then basically what you do is you, so I can request, I have to show because this is a get query. I can show you here in the extensions, it's actually like, yeah, it's the syntax that I just showed you. I put it in here, so it's passed inside the query, and if I send this, it's going to give me the error, right? So persistent query is not found. Yeah. So what actually happens if I do this same request and I provide the actual query, and I know in this case I did send like the query inside the URL query, but I'm almost 100% sure that you should be able to pass it in the body of a post request, but I couldn't get it working yet. So because otherwise it wouldn't really make sense, right? That if you have a really large query and you can't put it in here, then the whole thing doesn't really make sense. But I just want to show you that if I run this query, it will. Oh, I have to switch this. It will give me back all the people, and if I now request this only based on the hash, it will also get the query, right? And I think I can show you real quick here that this is my Redis interface, and it's showing like this is the hash. It's called APQ, so that's like the automatic persistent queries. That's the package that is used, and then you can see here that it actually knows my query. So now I can get this query by hashing it. And this is one thing that I also want to mention for security wise. Now you can also say, okay, only allow all queries that are like this hash. So then you can whitelist what hashes actually are allowed. So you can just set the exact queries that clients can perform, and you can of course generate that from client-side code and then inject that into the backend at build time. Okay, I think that's it on performance. Those were the two things I want to show you. I have a couple of more on security. So the first thing is like, if you're looking at GraphQL, you see all the nesting, and you. Oh. Okay, I have to get this done really quick, I guess. But you can understand that if you have for example, a recursive relation, you can endlessly go deep, right? So you can ask for the friends of the friends of the friends of the friends, and so on. And there are a couple of things that you can do. I'm going to show you that real quick. What you can do is you can provide a depth limit. So this is basically also a package that I used. It's really easy to use in the end. Switch this to case 5, and I get a person. I set it on 3, so this should work, right? So it's getting the friends of the friends of me. But if I request their friends, then it's going to tell me that, okay, this exceeds this is the operation name. I didn't provide the operation name here. But it's exceeding the depth. And the same thing, you can also do this with complexity. So you can understand that if you do depth, but you have like a lot of different fields. So if I only have friends here right now, but if I have friends and parents and blogs and a lot of different relationships, then it's like you can create a really large query without going in really in depth. Is this? Complexity, yeah. So yeah, complexity takes into account actual like relationships, and it uses like, I think scalar types in GraphQL are given 1 point, and then object types are given 10 points, and then you can give in some number, and it will give you errors if you're going past that thing. So I think I'm already exceeding the limit. Yeah, it said query exceeds complexity limit. and if I request less, then so these are like two really basic measures that you put in place. Like you can choose a pretty large complexity, but in the end, it's going to save you from like getting forced with really large queries. Yeah, and of course, what I just said about you can also limit persistent queries based on the hashes that you created. So that's that. Yeah, something that's a really big thing in GraphQL is the introspection query. It's very useful in development. It's also one of the things why when I press this, I can just, this IDE thing can see all the things that I have in my schema. And by default, I know that Apollo server. Oh, my introspection query is too complex. Okay, that sounds okay. So yeah, it's giving me. It's kind of hard to see, I guess, but it's giving me a lot of information about. Okay, there's a query for authenticate user, and there's a query for a person, and a lot of different things. But as you can see, I mean, if you leave this enabled in production, and I think most packages that you're going to use are going to disable this if you somehow set some environment variable to knowing that it's production, are going to disable it. But I just want to note that please take a look at your production and make sure that this thing is disabled, because it's like giving your whole, this is the blueprint of my API, just go try to hack every endpoint you can. I know there are also, like, if you guys know Metasploit and things like that, there are packages that can do automated hacks based on getting the introspection query. So that's, you kind of really make it easy for hackers to, test their stuff against your API. Yeah, and in Apollo, it's really easy. You can just, I won't show it, but you can just put it on false, and then it won't allow doing that. Yeah, and in Apollo server, it's disabled by default if you provide the node env as a production. Okay, masking errors, interesting thing. So if you're going to take a look at, this is interesting. For example, here I have the people query, right? I get all the persons, but what I want to show you, if I do this thing is going to throw an error. It has to do something with SQLize, because the query seems okay, but it's going to throw an error, and I'm going to show you what happens. Maybe I should make this a bit larger. It's kind of hard to see, but it's giving an error. Like it's actually showing the message, and then it's actually saying internal server error, and it's providing, like, it's actually showing me the error, and if I move down, I can even see, like, okay, there is some SQL statement, which I can clearly see, and I probably don't want to see this in production. Yeah, and so on. So what you can do in most, and what you should do in most implementations, you can provide a function for formatting the error. And then, of course, you should always just log your error to Sentry or whatever, like, error reporting tool you can use. And then I want to show you here two differences. Like, this is what you might do to fix my issue, right? So you're saying, okay, if it's a SQLize database error, I throw an error with something went wrong. And then you basically get, like, it's not refreshing. Yeah, it has to restart. So now I only get the message, and I don't get any more information. So that's great. But you basically don't really want to do this. What you can do is, if you have an error that you actually want to expose to the front end, then you should whitelist that, and basically always throw the something went wrong error, because you already are logging your error to your error reporting tool, right? So if your endpoint is showing this, it's not that much of a problem, because you can always look it up there, but you're going to need this if you want to expose some error information to the front end, basically mainly input validation or some kind of domain errors, something like that. Okay. Pagination is something that makes sense, but I won't go into the demo because of time. But yeah, what you sometimes see is that people actually set. Of course, you always have to set pagination, but then people forget that the limit should have a limit itself, right? The limit in the sense that I want to say, okay, limit my amount of queries to 1,000, for example, but you want to give that a ceiling, right? So give it like 20 at max or something like that. So I just can't type limit, give me 100,000, and it will give me 100,000 queries. So that's basically what this is about. And rate limiting is an interesting thing. Do I want to show you that? I think I can very quick. So that's basically rate limiting. Also really interesting, simple package. I think there are a lot of, like, for every ecosystem, there are a lot of packages that help you do this. This is a rate limiter for Express. It's what Apollo uses under the hood. And now I just said, like, okay, I can do a maximum of 2 requests each 5 seconds. So if I do a request here, it's going to give me I don't know, that shouldn't really matter. Should it? Okay, it does. This one works. Interesting. I think I didn't save it.
That will view 19.
Oh, yeah, you're right. I just run a function without actually doing something with the return value. Okay, interesting. Thanks for that, by the way. So if I run a query 3 times, it's going to tell me, okay, you're hitting a rate limit. Something that really is easy to implement, you can set it like on some value that you think, okay, my customers are never going to hit that actual value, but it gives you a good protection against DDoS attacks. And you see it provides the headers also with how many times you can actually perform the request, so the frontend can actually bail out for a given amount of time and then come back and do that request again. Yes. Okay. Yeah, this one is, I think this is one of the most important ones if you're going to do GraphQL.
We can go a little bit into overtime, right? Anyone wants to see the demo?
I think this is the last one, by the way, so, okay. I can show you real quick. What sometimes happens is that in GraphQL, you're creating like a really large graph, right? You're beginning with one entity, then you're adding another one, and over time you have like 20 or 100 or a lot. And if you don't do your authorization right on field level, then you have the risk that you are going to expose information through graph traversal. So that basically means that you can go from one object to the other, to the other, to the other, and then somewhere you can go back up, for example, to an entity that you shouldn't really be able to see. So in this case, I can show you the type definition again. For example, the user has a BSN, which you know, not everyone should be able to see everyone's BSN. But in my demo case, for example, I wanted to go from the person to a user because I wanted to get the user's username. But basically what I did by implementing this without authorization was that I could just say, okay, I can get this, or maybe go from authenticated person. So this is my query. I should switch this to 6. So I'm basically getting my own, okay, this should be fine. And I'm getting my own person because my user has a relation to the person, and then it's friends. But what I can do now, I mean, friends is also a person, so I should be able to get the user of that friend, and then I should be able to get its BSN. And actually I can, and these are things that happen that are really like, it's really hard to get that overview of that graph in your head and make sure that this never happens. So just, you know, when you're using GraphQL, know that this is a thing. And for the example, I can show you by, let me see. Oh, I have to be here. By returning null, for example, or throwing an authorization error, you can make sure that you can only see the BSN if my context user is the same as the actual user that I'm requesting here. So yeah, just make sure you put those checks in place, because otherwise it can be really easy to implement. Okay, I implement this feature, and then suddenly you made some kind of connections in the graph that can get any information from there. Yeah, I think that's about it. I'll put my slides online, so you can actually read through everything. You can test the code, see the code. I put in the comments in the code, so you can actually find, by looking at case 6 or case 5 or whatever. Yeah, thank you all for listening. I hope I gave some good information now, and yeah, thanks.
Thank you.
Are we going for the panel right now, or? Yes? Okay.